the first thing I want to explain to you guys is a little bit of theory. So a little bit of theory, a little bit of words. Often what we call theory in maths is we call it some maths lit. All right, so some maths literacy. Okay, so we're starting with the real number system. Okay, we're looking at the real number system. Now, when we're looking at the real number system, we're looking at all the ways that we name the real numbers around us. All right, I'm seeing quite a few different people saying that their screens are blank. So, Miss Simone, just to help them all out with that, I'm going to stop sharing quickly and then reshare just to help you out. So guys, just for those of you who are following along, your screens are going to go blank very quickly, and then I'm going to reshare so that all these people that are having issues, that should sort your problems out. Okay, let's do that very quickly. Let's reshare with all of you. And that should then sort everyone's issues out. If you're still having some issues, put your question in the chat and Miss Simone will help you out there as well. All right. So we're looking at the number system. Okay, we're looking at the number system. Now, all those words can sometimes be really confusing, but we're going to start right at the middle of these circles over here. Okay, so we're going to start right at the middle of these circles over here with what we call natural numbers. Natural numbers, and natural numbers starting with this letter, which is the letter N. Now, I'm sure you would have seen in your test in term 1 and in your exam now in June, where they asked you about natural numbers. Okay, so natural numbers, the letter N. How do we remember what natural numbers are, guys? How do we remember what natural numbers are? I've got a really nice summary on the side, which I'm going to bring up for you guys, which you're going to be able to screenshot. But for now, when I think of natural numbers, I try to remember to myself, what comes naturally for me when I start counting? Think back to when you first started counting at school. All right, when you were in like grade 1, okay, maybe even primary school. Good, Tammy. Natural numbers start from the number 1. So it comes naturally to start coming from the number 1. 1, 2, 3, 4. So natural numbers start from the number 1. 1, 2, 3, 4. It comes natural to start counting from number 1. All right. Then you'll see that my next circle then goes around whole numbers. All right, and the symbol for whole numbers has N-O. Okay, how do I remember that whole numbers has the 0 in it? Well, I remember that whole numbers starts with 0 because there is a 0 in the word whole. Okay, so that's how I remember that whole numbers starts with 0 because it's got a 0 in the word whole. So whole numbers, I'm going to have 0, 1, 2, 3, etc., etc., etc. All right. Then we move out again, and we move out to integers. Now, integers has a Z next to it. Okay. Often people get really confused here when we say integers. Okay. Integers, all right, doesn't just mean negative numbers, guys. All right. Integers means anything that's a negative number, so -2, -1. It also includes 0, and it also includes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Okay. Our next number that we get to, or types of numbers, then goes to, good, Abu, it's positive and negative numbers. Fantastic, well done. The next lot of numbers we get to are rational numbers. Okay. Rational numbers are represented by a Q. When I think rational numbers, okay, when I think rational numbers, to me, a rational number is anything that can be made into a fraction. So that's what a rational number is. So anything that can be made into a fraction. Tammy said it really well there. She said anything that can be written as A over B. So any number that can be written as a fraction, okay? So anything that can be a fraction. So guys, I just want to remind you that that includes things like the number 4. So the number 4 is actually a rational number as well. Okay, the number 4 is actually a rational number as well. Good, Abu, because 4 can be written as 4 over 1, which makes it a rational number. Fantastic, all right? Or we could also say that the number, the square root of 25, is the square root of 25 a rational number? You guys tell me in the chat, is the square root of 25 a rational number? I'm seeing one person, yes, yes, good guys. The square root of 25 is a rational number. Why? Because the answer will be positive or negative 5. So yes, the square root of 25 would be a rational number. Good. Irrational numbers, which is that Q, okay, which is the Q that has that little dot next to it. So irrational numbers, which is the Q with the little dot next to it, with that little dash, okay, irrational numbers, which is the Q with the little dash, is any number good. That is any non-recurring decimal, good. It is pi and any non-recurring decimal. Fantastic. So in other words, why is it pi? Because pi is the number 22 over 7. And if we say 22 over 7 on our calculator equals, it'll give us a decimal that is like 3,14, it'll carry on going and going and going and going and going and going. All right. Or if we do like the square root of 3, that will be irrational. Okay. So anything that's an irrational number is anything that is a non-recurring decimal. If you had to do something like 1 over 3, well, 1 over 3 is 0,3 recurring. Because it's 0,3 recurring, is that a recurring decimal? Yes, it is. So is that irrational? No. All right. So what would we say? We would say that this number is rational. Okay. All right. Cool. So what I've done for you guys is I went and I got a really nice summary for you that I thought might be a nice little screenshot moment here. Okay. So a nice little screenshot moment. It's got a nice written summary, okay, of all the different things that we've spoken about here. So what I'm going to do is I'm going to make it a little bit smaller for you. Oh dear. Okay, I'll make it a little bit smaller here for you with that drawing so that you can take a really nice screenshot. All right, what do we call everything that's inside that circle? We call everything inside that circle real numbers. So while you're taking a screenshot, I see that I've got a hand up here. It's Anya. Anya, do you have a question for me?
Yes, I would like to ask, on rational numbers, does that include mixed fractions or improper fractions?
So Anya, if it has a recurring decimal, then yes, it will be a rational, a mixed fraction can be a rational number. So if you've got like 4 and 1 over 3, which is the same as saying 13 over 3, then yes, that would be a rational number here, okay? Because it's going to have a recurring decimal. Does that make sense?
Yes.
But if it's going to be 22 over 7, that's not going to be a rational number. Why? Because it's not going to have a recurring decimal. Does that make sense?
Yes, it makes sense. Thanks.
Okay, good. You're welcome. No problem. All right. Okay, I'm seeing, can I zoom into the definitions? Of course I can zoom into the definitions for you. I hope that those people who want a picture of the whole screen has got a picture of the whole screen. I'm going to go zoom into some of the definitions, so some of the people who want zoomed in pictures of the definitions can get those as well. We have spoken about all these definitions, but there is a zoomed in image. I'm going to give you a few seconds if you want to take a screenshot of the zoomed in definitions. All right. So a few seconds there. Yes, Simone.
While we're waiting for screenshots, I saw a question in the chat that I'm sure actually a lot of people are confused about. The question is, what is a terminating and a non-terminating decimal?
What is terminating and non-terminating? Okay, great. So I see it there inside the definitions. So thank you so much, Simone. Terminating and non-terminating, it's the same thing. Terminating is the same thing as recurring, guys. So recurring means that it's going to carry on forever and ever and ever. And so it can either be terminating, so a finite decimals, or repeating. Repeating means that it's recurring. So if it's terminating, it's going to be like, oh, sorry. So terminating will be like 0.25, whereas repeating will be like 0.333333333333333333 into infinity. All right. Okay. All right, and non-terminating, I see it there as well. Non-terminating is also going to be irrational. Good. Non-terminating, irrational as well. Good. All right. Fantastic, Abu. Good. Okay, I'm going to move it down for you guys. So those people who want to take a screenshot of those last two. And then we're going to go fill in the table together. So we're going to go fill in this table. Okay, I hope that you guys have got that down. Let's move across. All right. And let's go fill in this table together. So I think that most of you would have seen this table before. I'm sure that you've probably got it somewhere in a test or an exam or probably an exercise somewhere. Okay, I'm sure it looks pretty familiar. All right. The question normally says, okay, the question normally says to you, Lorata, I see your question. I will definitely answer your question. Okay, so the question normally says, place a tick in the column, all right, with under which description best suits the number. You may have more than one tick in the column. So I would suggest go very quickly, write out a rough table for yourself on your page. Okay, I'm going to answer Lorato's question in the meantime and do some of those, and then I'm going to take some answers from you guys. So Lorato's asking me, ma'am, how can you identify a recurring decimal from a non-recurring decimal? Lorato, the best way to do that is to use your calculator. Okay, so you are going to use your calculator. If on your calculator, okay, I'm going to make this a little bit smaller and I'm going to bring my calculator up here for you guys. Hopefully we'll be able to use my calculator. Let's see what it gives us. Okay, so I'm going to bring that across there, Solon. Let's bring my calculator up on the screen for you guys, if it lets me. Oh dear, it doesn't want to bring my calculator up for you guys. Let's see. Nope. That's so odd. Where is my calculator hiding from you guys tonight? Oh, there we go. Okay, so I'm going to bring my calculator across for you guys and I'm going to show you. So if let's say they gave me a fraction and they said to me that the fraction was 1/6, and I needed to work out whether it was recurring or whether it was non-recurring. Well, 1/6 is the same thing as saying 1 divided by 6. So 1/6 is the same thing as saying 1 divided by 6. So 1 divided by 6 equals K. And on my calculator, it says to me 0.166666666666666666666, and then it says 7. Okay, So what my calculator's gone and done is it's gone and it's actually given me a, it's rounded off the last decimal because it can't put all the decimals on the actual screen, which means it's rounded off that last one. So is that a recurring decimal or a non-recurring decimal? Okay, is that recurring or non-recurring? Who can tell me? Is that recurring or non-recurring? I'm seeing yes, yes. Good, guys, that is recurring. How do I know it's recurring? Because that 6 is repeating, hey? It's carrying on and 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 on into the future. So because it is a recurring decimal, okay, is that number going to be rational or is it going to be non-rational? You guys tell me, is that a rational or a non-rational? Good, it is a rational number. Good, it is rational because it is a recurring decimal. Also because it can be made into a fraction. All right, so let's continue here and let's see what you guys have got so far. All right. Am I going to have some assistance with some answers here tonight? What's going to happen here? Let's see. Anyone who's looking to help me out? Any hands from the grade 9s tonight? Oh, I'm not seeing any hands up yet. Come on, guys. Are we still busy? Should I give you 1 or 2 more moments? Tammy, I see your hand up. Good. Good. I'm seeing more hands go up. Well done, guys. Okay, I'm going to give you 1 or 2 more minutes. All right, good. Well done. That is much better. I'm seeing more hands. Okay. All right, I think I'm seeing a lot more hands go up here. I am almost ready to get some answers from you guys. Okay, let us start with Tammy. Tammy, you were the first hand that was up. Tammy, are you ready to do 6 with me? What were your answers for 6?
Hi, ma'am. Yes, ma'am, I'm ready.
Hi. Okay, let's go, Tammy. Tell me, what did you say for 6?
Ma'am, so I say 6 is a natural number.
Fantastic.
It's a whole number.
It's a whole number. Good.
It's an integer.
Great.
It's a real number. I mean, it's
a real
rational.
number.
Good.
Good. It's rational. Good. And it's real as well. Hey, fantastic. Well done. Thank you so much.
Pleasure, ma'am.
Thanks, Tammy. That was a nice, easy one. Well done. Okay, Yinzeka. Yinzeka, are you going to do the square root of 8 with me? That's a little bit harder. Am I right?
Yes.
Yinzeka, let's go. What is the square root of 8? Which columns is that going to fall under?
It's not a natural number. It's not a whole number. It's not an integer. It's an irrational.
It is irrational. Well done. Great.
And a real number.
And it is a real number. Thank you so much. I feel like because you only had to tick 2 there, let's do the square root of 16 together as well. Let's go.
It's a natural number.
Good.
It's a whole number.
Fantastic.
It's an integer.
Great.
It's a rational number.
Good.
And it's a real number.
Well done. Nice. Thank you so much. Well done. Okay. Let's go with Kudlua. Kudlua? You should be able to unmute yourself. Okay, I'm going to come back to you. Lutando? Lutando, it should be able to unmute yourself. Lutando, on your screen, there should be a pop-up that says unmute. There we go, Lutando. Okay, Lutando, let's do negative 12 together.
Negative 12 is not a real, it's not a rational, it is a natural number.
Good, it's not a natural number, good.
It's a whole number.
Is it a whole number, are you sure?
No, it's not a whole number.
Good, it's not a whole number, good.
It is an integer.
Well done, it's an integer, great.
It is irrational.
Hey, is it irrational? Can I make it into a fraction, negative 12? Can I put it over 1? I can, hey? So it's going to be rational.
Yes.
And it's definitely going to be real.
And yes.
Well done, Lutando. Thank you for your help. All right, guys. So I'm going to do some of the next ones with you guys so that we can get through them a little bit quicker. So I've got 5 over 8. So if I look at 5 over 8, I can say that 5 over 8 is going to be a rational number, and I know that it is a real number. If I look at 0,6 recurring, I know that 0,6 recurring is going to be a rational number. How do I know that? Because it is recurring. We said that earlier. And I know that it is a real number. If I look at pi, we know that pi is the most famous irrational number, and we know that it is a real number. The number 0, what do we know about the number 0? We know it's the most famous whole number. We know that it is an integer. Okay, we know that it can be made into a fraction, so it is rational. All right. However, we can also say that actually it can also say that it is also irrational, and it is a real number. What do we know about negative 11 over 3? Well, don't get tricked here. Just because it is a negative, what some people go and say, well, oh, it's a negative, which means that it must be an integer. No, don't let them fool you. Because it's a fraction, it can't be an integer, guys. Okay? So negative 11 over 3, because it is a fraction, we need to say that it is a rational number and it is a real number. And finally, negative root 25. Well, the negative of root 25 is an integer, because when we square root 25, we get 5. It is a rational number, and it is also a real number. So I hope that you managed to do all of those, and I hope that you got the right answer. Okay, make sure that you've got a screenshot of all the correct numbers. So make sure that you've got a screenshot of all the correct answers. I'm going to go back here quickly in the chat and have a look and see if there's any questions. I see that Tato did send me a question on a private message and said, why is pi a real number? Well, guys, all those numbers are real numbers. The only number that wouldn't really be a real number is if you had to get something like this. If you had to get the number 14 over 0, then that number wouldn't be real. That number would be what we call undefined. Okay, so only over when it's over 0 is it undefined. All right. Okay, so I hope that you've managed to get all of those in. I hope you've taken a screenshot of that page and that you've got it all recorded. All right. So now we're going to go and have a look at some calculator skills. So I see that somebody's asking that they hope Miss Katz put a brain break in. So you can kind of classify this as a brain break because you're not really doing any maths as yet while we're having a look at the calculator skills. Still requiring you to do a little bit of thinking, and we will have a little bit of a brain break a little bit later on. But for now, let's have a look at some calculator skills. So I'm hoping that most of you have a Casio calculator. That's the one that at most schools they do ask you to get. So it's normally a Casio calculator. I do think that most of you guys are getting Casio calculators now when you're in grade 9. If you haven't got a Casio calculator, then a scientific calculator normally has most of the same functions as the Casio calculator. But tonight we're going to have a look at how you do HCF and LCM and get your prime factors using your Casio calculator. So this is a skill that you can do using your Casio calculator. Okay, so we're going to go across to the side here, and we're going to have a look at using the Casio calculator for prime factors. So I hope you have your calculator in front of you. Okay, if you do have a different kind of calculator, see if you can try follow along. Unfortunately, I don't have the instructions for the other types of calculators, and because they didn't have the instructions for the others, they only had the Casio calculator, unfortunately, and that is the most popular one. So we're going to have a look at the Casio calculator instructions. So before we even start with factors, it's a good habit to always reset your calculator. So we're going to try and reset your calculator. Okay, we're going to reset your calculator. All right. So for those people who are working on MacBooks tonight, I know that maybe you want to use the screenshot function. And so I'm just going to go over very quickly how you can screenshot on your MacBook as well. To screenshot, if you're using a MacBook, you're going to press the Command, Shift, and the number 5 button. So if you're working on a MacBook, you're going to press Command, Shift, and 5, and that's going to help you to take a screenshot on a MacBook, guys. So I know I did just get a question like that. Miss Simone also just got a question like that. So if you're working on a MacBook and you're wanting to take a screenshot, Command, Shift, and 5. So first thing you're going to want to do when you're using your Casio calculator is you're going to want to reset your calculator. So you're going to press Shift, you're going to press 9, you're going to press 1 equals, and you're going to press AC. So first you're going to reset your calculator, guys. So you're going to clear off your calculator. Okay. Prime factors can be found using what we call the fact key. Guys, I love this key. It is my favorite key on the whole calculator. Why? Because it is actually life-changing. Okay, it's life-changing. All right. It helps you so much when you're doing prime factors. It's going to help you so much when you're doing the HCF and the LCM. So shift, so we're going to use the fact key. Okay, where do we find the fact key? If we want the prime factors of 4,200 on our Casio calculator, we need to enter the numbers in our calculator and then factorize it. So in order to do that, you're going to bring your calculator up and you're going to punch in 4,200 equals. Then you're going to hit the shift button on your calculator. Do you all see the shift button? It's like that little yellow one. And then, see, I'm going to make it really nice and big on my screen. The key that you're looking for on your calculator, your Casio calculator, looks like this. It's got a dot and it's got 3 commas next to it. So it's got a dot and it's got 3 commas next to it. All right. So on your Casio calculator, 4,200 equals shift, dot, and those 3 commas next to it. You see that comma, that button? When you do that, this should come up on your screen. It should tell you that the prime factors of 4,200, okay, are equal to 2 to the power of 3 times 3 times 5 to the power of 2 times 7. Okay. What happens if you do not have a Casio calculator, but you rather have the Sharp? Unfortunately, the Sharp calculator doesn't have this function on it. So only the Casio calculator has this function on it, okay? If you have the Sharp calculator, then you're going to do the old school way to find your prime factors, okay? It says here, ma'am, do you press them at the same time? No, you don't press them at the same time on your calculator. You put 4,200 on your calculator like you normally would. You press equals, then you press shift, and you press that button. Okay, ma'am, for Casio, I don't see it. All right, have a look on your Casio calculator. It's somewhere near underneath the shift button. That's this little button. It is there. I promise you. I can see some people saying that they found it. All right. It even says fact on it in yellow and really, really tiny writing. It says fact. Okay. All right. Let's have a look and test whether this actually is right, guys, by doing it the old school way. So if I use a factor tree, I've got 4,200. And the first factor that I can see going into that is the factor of 2. 4,200 divided by 2 gives you 2,100. 2 can go into 2,100. It goes in 1,050 times. 2 can go into 1,050. It goes in 525 times. Okay, what's my next factor? What's the next common factor? Well, I see the number 5 going in there. So I'm going to put 5. 5 goes into 525, 105 times. 5 can go into 105. How many times does it go in there? It goes in 21 times. What's the next factor that can go in there? I can get 3. 3 goes into 21 7 times, and 7 goes into 7 once. So when I go and I write this as a product of factors, I get 4,200 equals 2 to the power of 1, 2, 3 times by 3 times by 5 to the power of 1, 2 times by 7. Is it the exact same thing as what the calculator did for me? Exactly the same. Okay, so the ladder method, doing it the prime factor ladder method or the tree method, whatever you called it at school, all right, exactly the same as if you're using the calculator. Obviously, doing it on the Casio calculator is just going to be a lot quicker. All right, so I'm going to bring up this instruction for you again so you can take a screenshot of that. Okay, so there it is for you to take a screenshot so that you can save that somewhere. Okay, so that you can save that somewhere. I am seeing somebody say that the old school way is better. All right, some of us do prefer the old school way. I'm sure Simone and I will agree that yes, we like the old school way. Okay, all right. Okay, so while you're taking a screenshot, I see that I have a hand up. Lutando, what's your question? Lutando, you should be able to unmute yourself. Okay, I'm going to answer the question that's in the chat so long while Lutando is looking to unmute themselves. Do you get it wrong if we don't use the power number? No, no, you don't get it wrong. You can write it out all the long way. So you can say 2 times 2 times 2 times 3 times 5 times 5 times 7. That's fine as well. Obviously, it's just quicker to write it out. 2 to the power of 3 times 5 to the power of 2 times 7. Okay. People have many ways to do their calculations. I completely agree. The Casio calculator has all of this information. Yes, CM Tanda, you are right. On the back of the Casio calculator, there is a little page there and there are instructions there on how to use that. Not everybody always reads that. Some people lose that page. And especially if you guys are going into exams and you have that page in your calculator, some teachers will even think that you might be cheating if you have that page. So just be careful is all I'm saying. Okay. I'm going to go to Goitsele, sorry, Goitsele, do you have a question for me?
Hi, ma'am. It's Hoiti.
Hi. I'm sorry, Hoiti. How can I help?
I was asking for the ladder method. I see that you said for 21, it's 3, but we were taught that when the numbers go up, it will be like 7 for 21, not 3. So if Arodi was gonna fix,
yeah, Hoiti, it doesn't really matter. It doesn't really matter. So whichever number that you think goes in next. Technically, I should have gone 2, 2, 2, and then I should have gone 525 divided by 3 first. You know what I'm saying? And then only 5, but
Yes,
it
ma'am.
doesn't actually matter as long as you get the same. Can you see it's the same numbers?
Yes, ma'am. So the
Okay.
order does not really matter.
Doesn't really, as long as
Okay,
you get the
ma'am.
same prime, as long as you use the prime factors.
Okay, ma'am. Thank you, ma'am.
Okay, you're welcome, no
Mhm.
problem, as long as you get the same numbers, okay?
Okay, ma'am.
All right, guys. Okay, so I hope that you learned something there. I hope that that will help you when you're doing this. And so now what I'm going to go and teach you guys is how do you use this now when you're doing HCF? So how are you going to use this when we're doing highest common factor now? So we're going to come across here and we're going to have a look at the first question. So 7.1 says, using one of the above methods, so whichever method you want to use, okay, find the HCF of the following pairs or groups of numbers. Okay, and they gave you 18 and 27 as your numbers. All right, so if I've got 18 and 27, okay, I'm going to have a look at this, all right, and I'm going to say, first of all, I'm going to set it out really nicely. So I'm going to start with 7.1. So it's really important to get your layout really nice. So I'm going to say 18 equals. All right, 18 equals. Okay, guys, somebody is unmuted. I'm not sure who it is, Miss Simone. I know it's not Lutando because Lutando still is not able to unmute themselves. All right, so 18 equals. Okay, what I would like you guys to go and do is, for those of you who do have a Casio calculator, I'd like you to go and try. I'd like you to go and try and say 18 equals shift factor, that factor button, so the dot and the 3 commas, and see what you get. So 18 equals shift factor and see what you get. Awesome, Palisa, well done. I hope that you use the calculator for that. Okay, anybody else? Well done, guys. So you get 2 times 3 to the power of 2. Well done. I hope that you guys managed to use the calculator for that one. And then we have 27 equals. And if we did 27 equals, okay, 27 equals, how do we do that one? What do we do if we do 27 equals? So 27 equals shift, and we press that factor button again. Good, well done. 3 to the power of 3. Well done, guys. So now I'm looking for my HCF, my highest common factor. Okay, so when I do highest common factor, okay, when I do highest common factor, I always say to myself, if I'm looking for highest common factor, okay, when I'm looking for highest common factor, all right, I think to myself that this F in highest common factor, I know it means factor. I know that. I know it's highest common factor. I know that. I've been highest common factor since I was in like grade 7. I'm cool. I know that means highest common factor, okay? That highest common factor to me, all right, I'm thinking that highest common factor means friends. So in other words, I want to know, how are these numbers going to become friends? All right. Now, when you want to be friends with somebody else, okay, literally you want to look the same. Okay, you don't want to embarrass your friend, you don't want to like outshine your friend, okay, you want to be friends. All right, so if I'm looking at my two numbers, 18 is the same as saying 2 times 3 squared. So let's start with the 2's. In 18 I've got a 2. In 27 do I have a 2? No, I don't. So do I want to embarrass my friend by putting a 2 in the highest common factor? Nope. Okay, I don't want to do that. All right. Then I move on. I move to the 3's. Okay, I've got 3 to the power of 2, and I've got 3 to the power of 3. Am I cool with putting a 3 down? Yes, I am, because they both got 3's in them. So I'm happy to put a 3 down. That's all good. All right. Then I've got 3 to the 2, I've got 3 to the 3. So which one am I happier putting down? I'm happier putting the smaller power down. Why? Because I don't want to go embarrass my friend, okay? I'm happier putting the 3 to the 2 down. Everyone's happy like that. So we're going to put 3 to the 2. Why 3 to the 2? Because 3 to the 2 can go into 18 and it can also go into 27. 3 to the 2 is the same thing as saying 9. So 3 to the 2 is the same thing as saying 9. All right, guys, while we're here, and just to finish off, let's talk about the LCM quickly. Let's talk about the LCM. When I'm doing the LCM, I'm not worried about being friends anymore, okay? I don't want to be friends anymore. There's no F involved left here, all right? Now I've got M. Yes, I know, LCM means lowest common multiple, yeah, whatever, grade 7, I've been doing it since then, okay? All right? But when I'm doing it, I think that the M stands for the maximum. Okay, so to me, when I'm doing this, all right, M stands for the maximum, all right? So I'm going to take everything now. I'm not worried about being friends. I don't care about getting anyone's feelings hurt. I'm taking everything, the maximum of everything. So I'm starting with the 2's. That's the maximum 2's. There's no powers, there's nothing, so the 2's. Times by, what are the maximum 3's? The maximum 3's are 3 to the 3. All right, finish them off. 3 to the power of 3 is 27. 27 times by 2 gives me 54. All right, so I hope that really helped you tonight. I hope that you learned some calculator skills here. I hope that it went over some revision. I hope that you went over some common words again, whole numbers, natural numbers, that you got some screenshots, okay? That you learned to use your calculator in tonight's lesson. I know that we didn't have lots of big brain breaks, but hopefully we will have some more on Thursday when you also come back to get your test results, okay? Remember that on Thursday we will be having another quiz. Miss Simone is going to put up your poll for this evening, so please make sure there are 143 of you in tonight's class. Miss Simone and I would like all 143 of you to please answer the poll for this evening before you log out. But otherwise, please make sure you answer the poll, and we will see you guys all on Thursday when we will be doing, let me just double check the Thursday night's lesson for you guys. On Thursday, we will be doing exponents. Okay, so we will be finishing off this lesson and we will be moving on to exponents. Thank you so much, guys. Miss Simone, would you like to say anything?
Nothing from me, just a big bye to everybody.
Thanks, guys. If you have any questions, I'm happy to take questions for 2 more minutes and while the poll is being answered. So if you want to raise your hand and ask any questions, I'm happy to take questions for 2 minutes. Lutando, I'm going to try again with you. Do you want to try and answer and unmute yourself and ask your question now? Your hand is still up.
Yes, ma'am. Can I please ask?
Yes. Yes, Lutando.
Miss, can I please ask where where there was another method? Can I please ask where did you get the 3? Or how did you get it?
In this one over here, Lutando?
In the letter method, miss.
This one here?
Yes.
Okay, let's go do it together, Lutando. Are you ready?
Yes.
Okay, so I'm going to say 4,200. All right, Lutando, what's the first prime number in the list? What's your first prime number? Lutando, it's 2. Hey, your sound's just really bad. I hope it's okay. I'm going to mute you, okay? So, Lutando, the first prime number is 2, so I'm going to divide by 2. So 4,200 divided by 2 is going to give you 2,100. Then I say to myself, can I divide 2,100 by 2? Yes, I can. What does that give me? It gives me 1,050. Can I divide that by 2 again? Yes, I can. It gives me 525. Now, if I was doing the ladder method absolutely correctly, okay, like if I was doing it like our teachers when they like, you must make sure that you do all the numbers in order, blah, 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 okay, then what I would do next is I would say to myself, okay, well, 525, I must check first that the next prime number is the number 3. So I should take 525 and I should actually try to divide that by 3 first. And I see, oh, look at that. Can 3 go into 525? Actually, yeah, it can. So I would say 525 divided by 3 gives me 175. Then I would see, does 3 go into 175? Nope. So it would be 5 next. 175 divided by 5. Let's go and do that one on our calculator, just to make sure we get the right answer. 175 divided by 5 gives me 35. Can I divide 35 by 5? Yes, I can. It's 7. 7 divided by 7 gives me 1. So that means that 4,200 is equal to 2 to the power of 3 times 3 times 5 squared times by 7. All right, Litando, I hope that that helped. Okay, I'm going to answer one more question because I see that we still have about 30 people that haven't answered the poll, Miss Simone. All right, Christelle, you had your hand up first. So Christelle, you will be the last question. Christelle, how can we help?
Miss, can I ask, like, can I please get your number? So I want to ask you like a question, like privately.
So Christelle, unfortunately, I can't give you my private number, but you can send me a message on the chat. And what I can do is I can answer you on the chat. We can do that. Otherwise, you can also ask on the Watobe bot as well. But you can pop me a message on the chat and I can try to reply to you on the chat, okay?
Okay, Miss,
Thanks,
you.
Christelle. No problem. Thank you. All right, bye. Thank you. One more question. So I'm going to answer Amashle. Amashle, what is your question?
Ma'am, can you hear me?
Yes, I can hear you, Amashle. How can I help?
Ma'am, sorry, ma'am, I didn't see that my hand was up.
No, it's fine.
Let me lower it, ma'am. Ma'am, there's nothing to say.
Oh, you don't have a question? Okay, cool.
No,
Thanks,
ma'am.
Amashle. All right.
Okay.
Lesedi, what is your question?
Ma'am, I was asking, can you please explain for me the LCM for the last time?
Sure, of course I can, Lesedi. Should I do it with a different example? Would that help? Or is this one okay?
Yes, ma'am. Another,
Is this
like
one
with, ma'am, can you please use other numbers?
other numbers? Okay, cool. Let's have a look at another one with a different example, with the other numbers. Okay, so, all right, very quickly. Have you got a Casio calculator with you?
No, ma'am.
Oh dear. Okay, let's use the number 2. Okay, so I've got 15. 15 is going to be equal to 3 times by 5. You're really going to test my skills here, hey, tonight, hey? Oh, my goodness. Okay, no, wait. Let's do the other ones. Let's see if I can do the other ones in my head quick. All right, so we're going to say 24. 24 is equal to 2 to the power of 3 times by 3. And let's say 40. 40 is equal to 2 to the power of 3 times by 5. Do you believe me?
Yes, ma'am.
Oh, you're trusting, hey? Okay, sure. You're going to trust my brain. All right, okay. So first of all, we're going to do HCF. Now, we know what HCF means. It means highest common factor. Okay. Tell me, what does HCF mean to me? What does the F stand for to me? What did I say?
Friends.
Friends. Good. Okay, so let's try be friends, okay? So I'm going to put the 2 down. All right. And which 2? What am I going to say about the 2? Am I just going to leave it as 2? It's not, hey? What am I going to make it? I'm going to make it 2 to the power of 3,
3.
hey? Because what do my friends want to be? My friends want to look exactly the same.
Same.
Okay. Then
ma'am.
I see I've got a 3 on the top. All right. Do I have a 3 on the bottom?
No, ma'am.
Nope. So I'm going to put 3 down.
Yes, ma'am.
Definitely not, hey? I'm not going to put 3 down because my friends want to be the same.
Same.
All right. Am I going to put 5 down?
No, ma'am.
Definitely not because my friends want to be the same.
Same.
So that means that my HCF is going to be 8. Let's talk about LCM. What does the M stand for again? Can you remember?
Maximum.
Maximum. So I want everything now. Okay. So if I look at my 2s, are you happy? Oh, no. What's happening here? My goodness. What happened? What happened? Are you happy that I'm going to do my maximum 2? So I'm going to do 2 to the power of 3. Hey?
Yes, ma'am.
Happy? All right. Then what am I going to do with my 3s? Am I going to take my 3s now?
Yes, ma'am. I think so.
Definitely, yes, absolutely. I'm definitely going to take my 3s because I want everything. I want the maximum. I want everything that I can have. Okay. Times 3.
Yes, ma'am.
Am I going to take the 5s?
Yes, ma'am.
Yes, because I want everything. All right. So I've got 2 to the 3, which is 8. 8 times 5, which is 40, and 40 times by 3, which is 120. Doesn't make sense. Hello. I think we disappeared. Okay, we will go over it again on Thursday.